If you're looking to build a compact, power-efficient, and surprisingly capable home server, you are in the right place. Today, we are testing the ZimaBlade. Now, for the sake of transparency, the folks over Icewell were kind enough to send me the ZimaBlade NAS kit for review. However, they are not sponsoring this video, and all the opinions I share with you today are fully my own. I'm here to show you not just what works, but also what doesn't, and how to fix it. In this video, we'll go from unboxing and setup to stress testing the ZimaBlade with a full suite of apps like Plex and Seagate. We'll test its real-world capabilities, measure its power consumption, troubleshoot the software issues I ran into, and then push it to the extreme by connecting a full desktop GPU to see what this tiny server is truly capable of. And if you're ready, let's go! But first, you know who is sponsoring this video? That's right, PCBWay. If you're working on your own DIY electronic projects, PCBWay offers high-quality PCB manufacture, assembly, and prototyping services at affordable prices. I use them for my own builds, and their fast turnaround and excellent support make them a great choice for makers and professionals like us. During September, PCBWay will be offering a major discount on 3D printing products. Check out the webpage on the description to find more information. Thank you PCBWay for sponsoring this video. I've got the ZimaBlade itself, and a few essential accessories to get our project started. First, let's get this opened. The ZimaBlade 7700 uses a 4-core Intel Atom processor, paired with an Intel HD Graphics 500, 32GB of eMMC internal storage, and supports DDR3L memory. In the box, we'll find right on top a nice personal touch, a letter from Lauren, the founder of Icewell. Underneath that, the user manual, that we are definitely going to use. And here it is, the ZimaBlade. First impressions? It's got a nice heft to it, thanks to this combination of plastic and aluminum passive cooling case. Taking a tour of the I/O, on the left side, we have our two native SATA 3 ports. On the right, we got a mini display port for video output, a Gigabit Ethernet port, a USB 3.0 Type A port, and a full-feature USB-C port. And right on top, a PCI Express 2.0x4 slot. Then we got a 16GB DDR3 memory module. Underneath the foam insert, they include one standard SATA cable and a USB-C to USB-C cable, and of course some stickers. I also got this SATA white cable, since the included cable is for a single drive, but since our goal is to take this to its maximum capacity, this white cable that is sold separately is what we'll need. Next up is the power adapter. It comes with a full set of international plugs, which is great to see. We'll just snap the one that we need and it's ready to go. To get a standard video, we'll use this mini DisplayPort to HDMI adapter. It just plugs right in, and now we have a full-size HDMI output. Let's plug in the power as well. The NAS kit also includes a 2-bay HDD rack. This will eventually house our hard drives and the ZimaBlade itself, creating a single, tidy NAS unit. Since it's all metal, it should also help a little with heat dissipation. Alright, time to install the RAM. First, we need to get the case open. And I'll be honest, it was a bit of a struggle to get this plastic cover off. It's a very snug fit. With the cover off, we get a great view of the board's layout. And here is the SODIMM slot. Now, here's a quick tip. When you install the memory, make sure to push it all the way, until the clips on the side lock into place. When I first put it in, I didn't seal it correctly. You can see there is still a bit of gold connection showing. You should barely be able to see any gold when it's fully seated. I noticed that and fixed it off camera. With the memory correctly installed, we can close it back up. One of the most powerful features of the ZimaBlade is this PCI Express 2.0x4 slot on the top. This opens up a ton of possibilities for expansion. However, there is a design quirk. The position of the slot means that the case itself collides with where the standard PCI Express card will sit. So, to use almost any card, you'll have to remove this bottom plate. You can connect anything from a multi-gig network card to even a graphics card. Yes, a GPU. And I'm definitely going to show you how I achieved that later on the video. because adding a GPU clearly requires way more power than this little adapter can supply. The ZimaBlade comes pre-installed with CasaOS, which is a fantastic user-friendly home cloud system. So let's connect it, power it up, and start playing with it. I'm not going to deep dive into CasaOS today, that deserves its own video. But for a quick overview, it's a very similar concept to Home Assistant OS. They both use Docker containers to provide a simple one-click way to install and manage services from a single web interface. The main difference is that CasaOS' primary focus is giving you an out-of-the-box, simple NAS experience. Luckily, this includes Home Assistant, which is available in the CasaOS App Store. Well, it should be available. I immediately ran into a problem with the pre-installed version. The App Store was just stuck in this infinite loading loop. I did some digging on their GitHub page, but I couldn't find a definitive fix for this specific error. While I was investigating, I found out that even though the UI said my system was up to date, it was actually running an older version of CasaOS. Since CasaOS is based on Debian 11, I decided to try updating it manually. I found the official update script in their documentation and decided to run it from the terminal app built right into the web UI. Now, be warned, the update process can restart the web server, which can kill the terminal session mid-update, which is exactly what happened to me. So the process was cut off halfway through. The more reliable method is to connect directly to the ZimaBlade using SSH. I logged in and ran the same update script again, and this time it finished correctly. And that's it. The App Store is now fully functional and working perfectly. So, a small initial problem, but an easy enough fix. Here you can find the out-of-the-box, ready-to-install list of services. Now that I finally got the base system working, I decided to see how many services I use the ZimaBlade can handle. I started with Home Assistant, and everything appeared to be going great until it reached 87%. Then it took forever to finish, but eventually it did. Then I checked the configuration to see where it was storing the configuration files of Home Assistant. And then using the Files app, I found the Home Assistant folder. Everything seems well organized and easy to find, and you can open any of the services you install just by using the icon in the CasaOS dashboard. Then I installed Image to manage my photos library. And again, at some point it appeared that the installation wasn't moving, but I couldn't find any error. Just this Postgres is unhealthy message, but it disappeared after a page refresh. So if something similar happens to you, just give it a little time. Then I proceeded to upload a backup of my Home Assistant instance. And after it finished loading it up, as expected, the add-ons were not compatible, since this is only a vanilla Home Assistant installation, not the complete Home Assistant OS. And since this is not really an option for me, because I want to develop and use my own add-ons for the channel, I installed the CasaOS version and did a hybrid installation, using the Home Assistant supervised method that actually just got deprecated, so I don't recommend you to use it. Just know that there is a way, but it requires a more advanced configuration to get it working. Also, since until this point I was only using the 32GB of integrated storage of the ZimaBlade, I decided to add two Seagate 8TB hard drives, fuse them into a single 16TB virtual drive using MergeFS, and then proceed with the Home Assistant supervised installation. This let me fully restore my Home Assistant instance, including add-ons. Since this installation is not managed directly by CasaOS, all the Home Assistant related containers appear under a legacy app menu. Now that I got almost everything migrated to a new server, I decided to install Plex. This time I did a custom installation, since I wanted to install the Plex Pass version to be able to use hardware transcoding and see how the system behaves under load. Now, let's start with a simple read and write test. This is important to optimize the startup time of your server, since my intention is to load many services from this tiny server, and I don't want to wait 20 minutes after a cold restart to get everything up and running. First, I tested a SSD using a USB-C 2.0 connection, This, as expected, was the slowest, with a max read and write speed around 40 megabytes per second. Then I tested one of my Seagate hard drives, and I got 161 megabytes per second for writing and 236 megabytes per second for reading, a big jump from USB 2.0. Then I tested the integrated eMMC storage, and I got 146 megabytes for writing and 133 megabytes for reading. This is really close to the hard disk performance. And to finish it up, I tested this using the same SSD that I used at the beginning, but using a USB 3.0 connection. And again, as expected, with this I got the best performance, 240 megabytes for writing and 300 megabytes for reading, almost double the integrated eMMC speed. The first thing to notice here is how much of an impact using a USB 2.0 versus USB 3.0 has on SSD performance. So just make sure to be using the right adapters. And second, that the integrated eMMC storage is more comparable to a hard drive in terms of speed than to an SSD. So I decided to use a combination of everything: the eMMC to store the main operating system, the SSD to store the Docker containers data, and the two 8TB hard drives to store media files. Then I loaded up Image and started by uploading some photos from my phone. This quickly made it run up in CPU usage and temperature. Bear in mind that at this point it is processing every image by generating a thumbnail, scanning metadata like GPS coordinates to put your photos in a map. It runs a machine learning algorithm to find faces and detect duplicates, and then writes information to the database. So this was only natural. I added an external cooler to help dissipate the heat, since I was going to let it reindex my whole photo library, so it was going to take a while. The temperature reached a maximum of 58 degrees Celsius, which is about 136 degrees Fahrenheit. Then I noticed that it was only using the CPU, but the integrated GPU supported Intel QuickSync for transcoding videos, and OpenVINO for model inference. So I updated the configuration to use hardware acceleration to offload part of the task log to the integrated GPU. This is why I created an image installation script with GPU acceleration on my last video, since I had to do a lot of reading to understand how everything worked and what the different configuration options were. Check it out if you want to get image with hardware acceleration up and running super fast. After this change, although the CPU usage went down dramatically to only 34%, the heat got up to 72 degrees Celsius, about 161 degrees Fahrenheit, even with active cooling. This was due to the GPU usage. It was using almost 100% of the integrated GPU capacity to run the face detection model. You can see the clear CPU usage difference. While the CPU was almost 100% before, now it had some random spikes, but mostly stayed around 40%. I don't really like running a server at these temperatures for long, since it will definitely shorten its lifespan. So the first thing I did was to just deploy an image machine learning container on my PC to offload the machine learning task to the Nvidia FNIRI running on my machine. Again, I'm not going to show you how to set it up, just know that it is possible and that you can research if this is something that you want for your setup. This change impacted the temperature a lot. It went down to only 49 degrees Celsius, about 120 degrees Fahrenheit. But just when I thought that everything was going great, I started getting this random hard disk error. At this point, I started to test everything to rule out every possible scenario, so naturally, I ended up doing a full reinstallation. I was thinking of doing this anyway, since Debian 11, the version that CasaOS is based on, it's at the end of its life cycle. And you can install CasaOS over pretty much any Linux operating system using their script. So I connected a USB hub to the only USB port available on the board, since I needed to connect the USB drive with the Debian 12 installation image and a Logitech thingy to connect the mouse and keyboard for the setup. I chose Debian 12 because it's also supported by the Home Assistant supervised installation. After that finished, I ran the CasaOS installation script and got it up and running in no time. Then I redeployed all my services. Fun. And I decided to do a full Google Photos migration to Image, using ImageGo to automate the processing of the Google Takeout files. While doing a full import, the server managed to be at 46% of CPU usage, with some peaks of 90% from time to time. Also, something that I didn't show until now was the power consumption. On average, even with the integrated GPU activated, the power usage went from 20 to 39 watts, which was more than the 36 watts the power adapter from the ZimaBlade was rated for. So at this point, I needed more power, and I thought, well, if we are going to go this route anyway, why don't we just go all the way? So I decided to add a GPU to the mix. This is where things got interesting. For this, I used a spare PSU I had laying around. I had to use a jumper to make it think it was connected to a regular motherboard. Then I used one of the CPU cables and measured the voltage to confirm it was outputting 12 volts, like the ZimaBlade uses. Using the multimeter my friends from FNIRI sent me. This is super useful, and you don't have to worry about connecting it right. If you invert the polarity, meaning you measure the positive end with the negative probe, the value will just be negative. The important part is just confirming we got 12 volts and which one was the positive and negative, so I can create a connection with the USB-C cable. With that figured out, I needed a USB-C cable that supported 12 volt power delivery, so I could order one from AliExpress, or since this was time sensitive, I could just cut the USB-C cable from the original adapter. Again here, I'm not recommending you to do this, this is just for fun. So I grabbed my cable cutter and peeled off the cable. Then I gathered my soldering equipment and added some solder iron to each side to facilitate soldering. And then just solder the parts together. And that's it. Then I just needed to check that I was getting 12 volts. So again, using the multimeter, I checked the voltage. This is not just a multimeter, it's also an oscilloscope. It has a built-in 3000 mAh battery and charge using USB-C. I'll put the links in the description and on my website for all the products I'm using on this video. Then I proceeded to secure the joint using some electric tape. Lots of it, because why not? And finally, I got my 12 volt USB-C connection. So I was ready to put everything together, cross my fingers and see if it worked. Once I got video output, I just needed to connect over SSH to check if the Linux file system recognized the card before installing the drivers. So at this point, I was ready to configure all my services to start using the GPU from hardware acceleration. Let's see some of the results. I tested how well it could handle two concurrent transcoding processes, one from Plex and one from Image. I wanted to see if the PCI Express 2.0 by 4 port on the ZimaBlade would limit the performance. I compared it to the PCI Express 3.0 by 16 port that the card was designed for. The difference is significant. A PCI Express 3.0 by 16 can handle up to 15.75 GB per second, but the ZimaBlade's PCI Express 2.0 by 4 only supports up to 2 GB. That's more than 7 times less bandwidth, which will definitely create a bottleneck. And I can confirm that for operations that don't require heavy data transfers like video transcoding, and even some light machine learning models, so forget about gaming, the PCI Express 2.0 port on the ZimaBlade can allow you to give some superpowers to this mini server by adding a GPU. Just bear in mind that this changes completely its power usage profile. As you can see here, while running two transcoding processes, the power consumption stays around 80 watts, while before using the integrated GPU, it consumed around 33 under load, with peaks of 39, and it idled at 28 watts, with two hard drives connected. Just for reference, without any hard drive, it consumed around 13 watts while idled. You need to consider how the peripherals you add to your NAS will affect its total power consumption, since using a power supply that can't keep up with the power usage under load will definitely give you stability problems in the long run. The only thing left for me to try was adding Seagate to the mix, to see if it could handle a complete NVR system with 3 1080p cameras. And as you can see here, I was only using 1.5 GB from the 6 GB available on the 1660 Ti Nvidia card. So I think even something like the Nvidia 750 with 2 GB of RAM could handle the load. The inference speed wasn't great, to be honest. This is probably due to the speed limitation I was talking about earlier. So I ended up using the Coral TPU for inference and the Nvidia GPU for video transcoding. With this setup, it has been using around 55 watts while idle, with peaks of up to 80 watts under load. This is around 2.5 less what my desktop consumes, so for me, this is an excellent option. But know that you can choose to use low power consumption hard drives and get it to run at about 20 watts under load, and probably about 15 watts while idle. My system has been working great for the past 12 days. So I think it's safe to say that the ZimaBlade is a super powerful mini server that can be used with the right combination of hardware to handle most of the services that you will need for a pretty powerful self-hosting server. Now, for our local AI needs, I think the PCI Express 2.0 port in the ZimaBlade might not be fast enough, but probably something like the new ZimaPort 2 with PCI Express 3.1 port can give us a better result if you're looking for the ultimate self-hosting mini NAS. Again, all the links of the products I mentioned on the video will be in the description and on my website. And if you want help with Home Assistant, you can book a 1-hour meeting with me. As you can see, I don't take no for an answer when it comes to a problem. I found the solution. So if you have some configuration or network design problem, automation driving you crazy, I surely can help you find a solution that works for you. If you like my work, please consider becoming a member like all these amazing people. If you can't become a member, you can always donate whatever you like using the button on our website. And if you can't do that, don't worry. Just remember to leave a comment on the video and share it with your friends. I truly appreciate all your support. And don't forget to subscribe for more content like this. I'll see you in the next video. Bye!